Welcome back, Year 5. In today's math lesson, we're going to be looking at multiplying decimals by 10. Now, this is not a very tough lesson. It just requires a bit of practice to get the skill down pat. In fact, it's quite simple. What we're going to be doing is using our understanding of place value to develop fluency in multiplying decimals by 10. Now, that's just a fancy way of saying that we're going to get really good at multiplying decimals by 10. In fact, we'll be fluent in it. We'll be able to do it very easily and very quickly. So for our warm-up today, I'm going to show you one of the strategies for multiplying decimals by 10.
Let's start with a quick review of multiplying by 10. Remember, as you move from one place to the next, going to the left, you're multiplying by 10. It takes 10 ones to make 10, 10 tens to make 100, and so on. So if I had 3 ones and I wanted to multiply that by 10, the easiest way for me to think of this is just as moving it over to the next place. So it would go from being 3 ones to being 3 tens. Then, of course, because there's an empty space behind it and the decimal point is back here, I have to put my placeholder. So now it says 30. What if I had a 2-digit number though and I wanted to multiply it by 10? Let's say I had the number 15. Well, again, each digit is going to be moving. Because we're multiplying by 10, and as we move to the next place, you multiply by 10, I can take this 1 and move it to the hundreds place. Because this 1 is really not just 1, it's 1 10. So what's 10 10 times? 100. So this 1 would move over to the hundreds place. And the 5 in the ones place, well, if I have 5 ones and I multiply that by 10, it's going to become 50, which is 5 tens, so it just scooches over. So I can just imagine that these numbers shift place. And what do I need to do at the end? Fill my space with a placeholder. It's going to be a little bit different with decimal numbers though, so let's take a look at some decimal numbers. So on the left-hand side of your screen, you should be seeing the first problem that says 9.621 times 10. What I've done is I've put this number, 9.621, into my place value chart. Remember what I said, to multiply by 10, all we're doing is shifting the numbers over one place, because as you move one place to the left, everything is 10 times greater. So let's see what happens when I shift this number over. All right, I moved everything over just one place. So my 9 went from being in the ones place to being in the tens place. My 6 went from being in the tenths place to the ones place. And so on. The 2 went to the tenths, and the 1 went over to the hundredths. In this case, I do not need to put a 0 down. And the reason for that is that adding a 0 at the end is not going to change the value of my number. I have 96.21, or 21 hundredths, 96 and 21 hundredths. Putting a 0 on the end does not change that this is still 21 hundredths, or that this is 96. Let's look at this on paper now. It's the same problem, 9.621 times 10. Now, when we don't have a place value chart, we can look at it this way. Since I'm multiplying by 10, all the digits are going to move one place to the left because they're going to get bigger. We're multiplying, so things get bigger. So here's my decimal point. I'm going to keep my decimal point in the same spot, but all the numbers are just going to shift one place over. So instead of being after the decimal point, the 6 is now going to be in front of it. Once I've moved that 6, it's kind of easy for me to put everything back in place because all the numbers stay in the same order. So it's still 9, 6, 2, 1. And now I can clearly see how everything shifted one place. Ones to tens, tenths to ones, hundredths to tenths, and thousandths to hundredths. Everything scooched over one spot. So my answer is 96.21. Now, some people like using the trick of saying that the decimal point scooches over, so it went from being here to being here, which isn't a lie. We do now see the decimal point between the 6 and the 2, but always remember that the decimal point doesn't actually move, it's the numbers that have moved. So if you like that trick of saying, oh, it's just like my decimal point scooches over one spot, you can do that. But remember, you never say that that's what you did. You always say that all the numbers moved one place to the left. They became 10 times greater. Let's try that second question that you should be seeing on the left now. 4.7 times 10. Now, remember, when we're multiplying by 10, everything shifts over one place. A good way to remember why it shifts one place is because it has 1 0 at the end, one placeholder. So everything moves one place because of that placeholder. So here's my decimal point, stays in the same spot, but everything scooches over. The 7 is now in front. And since my numbers stay in the same order, the 4 should still be before the 7. So now I have 47 point nothing. Or I could put a 0 there. Of course, it's still just the number 47, so my answer is 47. Again, just to reiterate, if you like that trick of the decimal point moving, you can do that, you'll get the same answer, but we never say that the decimal point moved. We say that the numbers moved. Let's move on to C. 6.66 times 10. All right, still multiplying by 10, so everything is shifting one place. This 6 was behind it, so now it goes in front. And my numbers stay in the same order. So I put a 6 in front and a 6 behind. So everything has now shifted one place for the 1 0 that we have. Our answer, 66.6. I'm going to do one more with you, and then you're going to do the rest on your own. So this is D, 8.854 times 10. So we're moving everything one place because of that one placeholder. My decimal point goes back. This 8 that was once behind the decimal point is now in front of it, and everything else stays the same. So this moved here. I put my 8 back. I put my 5 back, and it's moved here. I put my 4 back, and it's moved there. So everything has shifted one spot. We went from being 8.854 to being 88.54. And I know my answers are reasonable because when I go back and check, I can think to myself, well, 9 times 10 is 90. And in my answer, it's 96.21. So it makes sense that this 9 went from being 9 to being 90. Similar down here, 4 times 10 is 40. So I should have 40 in my answer, and I do, 47. 6 times 10 is 60, and I have 60 in my answer. And finally, 8 times 10 is 80, and I have 80 in my answer. What I want you all to do for the rest of your warm-up is solve the other problems that are on the left-hand side of your screen. I know they're not lettered, just put a letter next to them like I have done and continue working through them, and then we're going to move on to the discover portion of the lesson. All right, now we've moved on to the discover portion. There I see in our picture that we have some students in math class, Kate, Richard, Rena, and Aki, and it looks like they're multiplying things by 10. Kate has said we need to multiply 0.1 by 10, and she's working with Richard and they're using a place value chart. At the other table, Rena said we are working out 0.11 times 10. And Aki said in response to her, the answer is 0.110, as you just need to add a 0. I think I see a problem with that, but we'll get there. The question, A. What is the answer to Kate and Richard's multiplication? Okay, well, Kate and Richard said that they're doing 0.1 times 10. Remember what we said before, all the numbers just shift one place to the left because as you move to the left, every place gets 10 times greater. So I'm going to keep my decimal point in the same spot and just shift the digits over. So my 1 goes from being behind the decimal point to being just in front of it. That 0 would now move to the tens place. If I put a 0 in the tens place, I still only have 1. because it's 1 in the ones place. So my answer here is just the number 1. That was pretty simple. Now let's move on to the B part. What mistake has Aki made? All right, so first of all, he and Rena are working out the problem 0.11 times 10. And Aki said that the answer is just 0.110. He just had to stick a 0 on the end. That doesn't work here. Remember, the numbers are supposed to shift over one place. If I had, say, the number 4 times 10, it would seem like I'm just sticking a 0 on the end like he said. But the reason why that has happened is because the 4 was in front of the decimal point, and it has now moved even further away from the decimal point. So there was a space before we get back to that decimal point, and that space needs to be filled, so we put a 0 in it. So when you're dealing with whole numbers, the trick of sticking a 0 on the end works, but when you're dealing with decimals, it doesn't, because this over here was 11 hundredths, and guess what? It still says 11 hundredths, no matter how many zeros I stick behind it. So this is not true. For me to multiply this properly, I need to move everything one place over. So I keep my decimal point, and everything shifts one place. So that goes there, which means the 1 goes into the next place over. 1.1. So I've figured out what mistake Aki has made. He just stuck a 0 on the end, which does not work. Not in this case, at least. It works with whole numbers. And the correct answer to Rena and Aki's multiplication is 1.1. All right, so we're going to move on to the think together portion. And I'm actually going to skip question 1 and 2, and we're moving straight on to 3. Because questions 1 and 2 are stupid easy, and I don't want to waste time on them. We've done a ton like that already in our warm-up, so let's just move on to question 3. It says there, complete the multiplications. I'm going to model how I will do A, and then you're going to do B and C on your own. Now, I'm doing exactly what we were doing before, just multiplying these by 10. But sometimes in your book, you're not going to want to have to draw a ton load of arrows and put stuff underneath. So remember what I said about it's kind of like moving the decimal point, although we never really move the decimal point, you move the numbers? Well, I'm going to think of it that way. So since I'm multiplying by 10, the decimal point is now going to appear after the 1. So I would write the 1, put my decimal point, and then there's nothing behind it, so 1.0. So 1/10, when I multiply it by 10, becomes 1 whole. The number shifted over. That 0 in front disappeared because putting a 0 in front doesn't change this number at all. It's still just going to be 1. For the next one, 1.2 times 10, I know all the numbers are what's moving, and the decimal point technically stays in the same spot, but I'm just going to visualize it as the decimal point jumping here, because when the numbers move, it's going to seem like the decimal point moved back. So now, the 2 is going to appear in front of the decimal point. And there's nothing after it, so just 12.0, or I could simply write 12. Both of these answers are correct. Writing 12.0 or 12, same difference, same value. Now for 5.7 times 10. Same thing, the numbers are moving, but a trick that makes it a little easier sometimes, just imagine that moves over. So now instead of appearing after the decimal point, the 7 appears in front of it. And of course the 5 stays in the same position. Notice the numbers always stay in the same order. 1, 2, 1, 2. 5, 7, 5, 7. Now the decimal point would be here, so it could be 57.0, which is the same thing as just 57. So I'm going to leave my answer like that. And finally for the A part, 19.1 times 10. Again, the numbers are going to move that way, so it's going to look like the decimal point moved this way. So it's going to appear there instead. So I'm going to end up with 191 point nothing, or just 191. Now, I cannot stress this enough. When you have to explain how you multiplied a number by 10, never, ever, 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 ever say that you move the decimal point. because the decimal point doesn't move. It's always in the same spot between the ones place and the tens place, always. The numbers are what have moved. So if you have to explain how you multiply by 10, what do you say? I moved the digits one place to the left, because as you move one place to the left, the places become 10 times greater. Go ahead now and solve B and C. You can use that decimal point strategy or you can use the arrows. It's up to you. Now it's time for the challenge. It says there, find the missing numbers in these multiplications. In A, we're doing 10 times 3.9. So we can use the same strategies we've been using before. Remember, we said technically the decimal point stays in the exact same spot and the numbers move one place to the left in order to become 10 times greater. So instead of having a 3, I'm now going to have a 30. And instead of having 9/10, I'm now going to have 9 ones. So everybody just scoots over. 9, 3, 39. Point nothing. So I can simply write 39 as my answer. Again, I'm going to say it again and you guys are going to get annoyed with me. The decimal point doesn't really move. I can do the trick of just saying, oh, I can just draw the decimal point here now. But in reality, the decimal point is always after the ones place. All right, on to the next one. 10 times 11.6. Now, don't get thrown because the 10 comes before the number we're multiplying. In all the other problems we've done, the other number came first and was followed by 10, but it's the exact same thing. So I'm multiplying 11.6 times 10. Decimal point stays in the same place. Everybody scooches one place over to the left. And they stay in the same order. So 11, or the two ones, should still come before the 6. 116 point nothing. So I can simply write 116. Now on to C. Something times 10 equals 4.56. Well, this is a little bit different because we don't know what number we're multiplying like we did up here. All we know is that the final product ended up being 4.56. Remember, when we multiply something by 10, all the digits scooched one place to the left. So if we want to undo that and see where we started, what do we need to do? Just scooch them one place back. So to get to 4.56, all the numbers scooched that way. So I'm just going to shove them all back one place and see where they were. So my decimal point was here. Oh, decimal point stays in the same spot, sorry. 5 goes over, 6 goes over. So the 4 goes from being in front of the decimal point to now being behind it. The 5 follows and the 6 follows. 0.456. Now, let's just make sure that this works. If I had 4.456 and I moved everything over one spot, the 4 ends up in front, then the 5 is right behind the decimal point and the 6 follows. So it does work going back and forth. What I really just did here to get my answer was the opposite of multiplying by 10. What's the opposite of multiplying by 10? Dividing by 10. So when I scooched all the numbers back, I just divided them. So I did the opposite of this in order to figure out where we started. So I did the inverse. 4.56 divided by 10 gives me my starting number. Let's try that with the next one because it's the same type of problem. Our first number is missing. We multiplied it by 10 and got this. So I'm going to divide it by 10 to see where I started. Decimal point stays in the same spot, but now we're moving everybody back one space. So the 2 goes behind the decimal point. And since everything else stays in the same order, I'm just going to stick them all back. The 1 was in front, followed by a 6, followed by a 2. 1.262. And I know it works because if I scooch this back that way, like I'm multiplying, I end up with 12.62. So 1.262 times 10 equals 12.62. I want you to now try and solve E and F. Remember, we don't know the starting point, so we have to work backwards. Instead of multiplying to find your answer, you're actually going to have to divide the product by 10 in order to work your way back to the starting point.
All right, Year 5, now it's time for your independent work. Today it comes from pages 39, 40, and 41. The first two pages are very straightforward because they just continue to focus on that skill of multiplying decimals by 10, which is exactly what we've been doing this whole video. Today the challenge, though, doesn't actually ask you to multiply by 10. It asks you to multiply by 20. Now I want you to think to yourself when you get to that one, what can I use to make 20? Two tens. That's all I'm going to say. I want to see how you go about solving it. And of course, don't forget to do the reflection at the bottom. And as always, Year 5, stay safe and I'll see you soon.